Okay, 7-9 says square root functions. The key there is it says functions. So, we're dealing with only functions now. A square root function is a function that contains the square root of a variable. The inverse of a quadratic function, so this is one we just talked about. The inverse of a parabola is a square root function only if the range is restricted to positive numbers. Okay, so for example, let me show you. Like I said, we just talked about this when we were doing inverses, right? One-to-one functions. So if I graph y equals x squared, that's just a plain old straight up parabola. So here I go. 1, 2 would be 4. So there's y equals x squared. Now think about reflecting this guy on the line y equals x. He'd end up being a sideways parabola. So let me show you that. So here we go. I'm just going to write my ordered pairs here so you can see them. At -2, I was at 4. At -1, I was at +1. 0, I was at 0. 1, I'm at 1. And 2, I'm at 4. Now, remember when we found the inverse, we switched the x and the y, right? Well, if I were to do that, I get 4 goes to -2, 1 goes to -1, 0 goes to 0, 1 goes to 1, and 4 goes to 2. What's happening? It's not a function anymore, right? So 4 is going to -2, and it's going to +2. So I get a sideways parabola, but it says it's inverse function. So I'm going to restrict my range, remember the ranges are the y's, to just the positive values. So this guy would be 0, 0, 1, 1, and then 4, 2. So when we talk about the inverses of parabolas, we get square root functions if we just have half of a parabola. Does that make sense? Let me also show you algebraically. So if my function is y equals x squared, when I find the inverse, I get x equals y squared. Well, if I want to solve that guy for y, I would take the square root. And technically, when I'm the one taking the square root, I get the plus or the minus out front. Would you agree with that? However, if I want it to be a function, that really means square root of positive x or square root of negative x. So we just pick one of them because we want it to be a function. Does that make sense? So everything we graph now is going to just be half of a parabola. Okay, let's talk about domains and ranges a little bit. Remember, the domains are the x's. If we're restricting our domains and our ranges, sometimes things change. Okay, so now just look at the red graph right here. Remember, I'm looking left to right. We did this last semester, it's been a while. But domains, I'm looking left to right. Is my graph in the negative part of my x-axis? No, he doesn't go over there, does he? Where does he start? At 0. So my x's are greater than or equal to 0. We can also see that from our table here. How about my ranges? My ranges are my y's. So I'm looking up and down. Do you see your graph in the negative part of your y-axis? Now, do you see your graph here? Remember, just look at the red. Do you see him there? Where does he start? 0. So my range is y is greater than or equal to 0. Okay. So sorry, JJ, yes.
What's wrong with like keeping the negative part of it?
He no longer then is a function. So if I were to graph the negative part, I'm going to put it in pencil so you can see it. So if I were to graph these guys, at 4 I would be at -2, at 1 I'd be at -1, and my graph would go like that.
Oh, it wouldn't pass.
It wouldn't then pass the vertical line test. Great question. So I want it to be a function so that it passes the vertical line test. Now, will we graph sideways parabolas? Yes, next chapter. Okay, so when we do these guys, we're going to throw them in our calculator, but you still have to tell me the domain and the range. Does that make sense? So we're going to use our calculator when we graph square root functions. We're going to use that table like we're pros, and then we're going to accurately put it on our paper. So this is what your homework's going to look like down here at the bottom. All right, so number 2. Let's put this guy in our calculator. So I want the negative square root of x. I just want you to see what the negative part looks like. I already did it up there. So we're just restricting it to really one or the other is really what we're doing. Does that make sense? Okay, so he looks like that. He's the bottom half of the parabola. So let's go look at our table so we can put him on our table. Look, it says error because I don't have that half of it. 0, 0, 1, -1, 4, I'm at -2. So the first thing you do is just throw it in your calculator.
I think we've had this problem before, but my calculator doesn't show the lines.
Oh yeah, your grid's out? That one? That's fine.
Oh, I've done that before.
Okay, so for the axis.
Did I make it white?
No, they were off.
Yeah, that would be a prank.
Okay, everybody see it okay on your calculator? Okay. You guys at home okay with your calculator? Okay. Now let's talk about domain and range for this guy. Where does my graph start looking left to right at my x's? 0. And it gets bigger, so x is greater than or equal to 0. When you do the domain, you should always use the variable x. How about my range? Where does it start? 0. And does it get bigger or smaller than 0? Smaller. So this guy would be y is less than or equal to 0.
I have a question.
Yes, sir.
On number 1,
Yeah.
it says that the domain. Oh, I was thinking. Yeah, the domain,
Uh-huh.
which goes that way,
Uh-huh.
it's greater than or equal to 0.
Right. So look at the red one on number 1. I started
we're talking
0.
about the red one.
The red one. Yeah.
What
ignore
about the blue one?
The blue is the original here because I wanted you to see where it came from.
Okay.
Yeah, so look at the red one on that one.
Yeah, I was
Yeah.
thinking
Oh, sorry.
about it.
Okay. You ready for another one? Okay. Now, remember we call that our parent function, right? The one that just starts at the origin and does everything nice and pretty, we call that the parent function. These guys right here, we're just going to be moving him around. Does that make sense? So we're going to still have that same general curved shape of half of a parabola. We'll just move him up, down, left, or right. Or sometimes both directions. Does that make sense? Okay, so any idea on what if we subtract 4? Where do you think he's going to go?
Down.
Down. Okay, so let's put him in our calculator. Square root of x. He's outside the square root, so he did indeed move down. So 0, I'm at -4. 1, 2, 3, 4. 1, I'm at -3. 4, I'm at -2.
Why do you switch whether it goes up or down?
So this one had a negative out front of the square root. This one doesn't. So the negative in front of the square root gives you the bottom half, or if it's positive, it'll give you the top half.
Got it.
Good question. Wyatt.
Why? I get something different.
Oh, so this guy, be careful that the -4 isn't in the square root on this one.
Oh.
So let him out of the square root. See if that helps. Okay, so what's my domain on this guy? X greater than or equal to 0, right? You can also see that on your table. That's the 0 is the first time I have a value. Okay, my range.
All the numbers. Really?
Do you see your graph below 4?
-4. X is greater than.
Yeah, y is greater than or equal to -4. Why did that get better?
Yeah.
You okay with that? Okay, Wyatt, not to put you on the spot, but what happened to your graph? So he put the 4 under the square root, kind of like this guy right here. What happened to your, did you look at it?
Yeah.
What happened to it?
Well,
He doesn't remember.
put it back.
So the guy outside moved it down, right? So if we added, so under it, he's putting it back in.
Backwards. Odd numbers go backwards.
It went up. When you put it back in the parentheses? Oh, it moved it up. Can I borrow your finger? It moved it up. Oh, right there. And to the right. So if it's under the square root, if the number's under the square root, it's going to move it left or right. So let's try B. Oh, hey, we totally went out of order. Things I never knew. So if he's under the square root, that moves it left and right. And remember, it's opposite of what you think. So x plus 2 moves it 2 to the left. Think back when we were doing B's. 2, 0, negative 1, positive 1, 2, I'm at 2. Okay, domains. You're looking at your x's. Where does that guy start?
X is greater than or equal to negative 2.
X is greater than or equal to -2. Perfect. What about my ranges? Y is greater than or equal to 0. Again, you can look at your graph. You can also look at your table. -2 is where my table starts without getting errors. Whoop. 0 is where my table starts without getting errors as well. Okay, last one, letter D. We're going to be moving this guy up and down, up or down, and left or right. Does that make sense? So the -1 is under the square root, and the +2 is outside. So this guy's going to move it up 2. This guy's going to move it right 1. See that? All right. Up 2, right 1. So at 1 he's at 2, 2 he's at 3, 5 he's at 4. Okay, so what's your domain for this guy?
I thought it goes opposite of what it's doing. So
If it's under it, it goes opposite. So
no,
see,
yeah, but
the outside.
The 4 brought it, the -4 brought it down. Oh, that's a plus.
Yes, that one's a +2.
Okay.
Yep, you're good. Okay, x is greater than or equal to 1. You can also see that on your table.
Y is greater than or equal to 2.
And y is greater than or equal to 2. Okay, questions on square root functions. So writing your calculator, tell me the domain and the range, right? Not horrible? Okay, let's look at your worksheet for that one. Last page. Woohoo! There's only 6 of them, but I do want you to tell me the domain and the range. So you're gonna graph it. I'd graph it first. Then tell me the domain and the range. Number 3, it just changes your slope a little bit. Okay? So still, just put that guy in your calculator, graph him, and tell me the domain and the range. All right, questions on anything?